person is standing with his arm outstretched in a horizontal position. The weight of the arm is 30 newtons and its center of gravity is at the elbow joint, 27.5 centimeters from the shoulder joint. The deltoid pulls on the upper arm at an angle of 15 degrees above the horizontal and at a distance of 12 centimeters from the joint. What is the magnitude of the force exerted by the deltoid muscle on the arm? So we know the arm is in equilibrium, so the net forces are equal to 0, and the net forces, or the net torque, is also going to be equal to 0. So first, to solve this problem, we will figure out the torque due to gravity. The force of gravity is perpendicular to the line between the point of application and the rotation axis, and gravity produces a clockwise torque of magnitude. So the torque of gravity is going to be equal to force times radius or distance, and we know the force is 30 newtons, and the distance is 0.275 meters from the center of gravity to the shoulder joint. So we had a torque of 8.25 newton meters. Here's my diagram of what's going on. So next we'll find the torque due to the force of the deltoid. So once again, the torque is going to be equal to the perpendicular force times the distance. And we know that the force is at an angle of 15 degrees to the horizontal axis. So the force of deltoid times sine of 15 times the distance of 0.12 meters is going to give us a torque. And so now that we have that information along with the torque from gravity, we can subtract the torque of gravity from the torque from the deltoid. So here's everything plugged into our new equation, and we need to find out the force from deltoid. So we have to get force on one side of the equation. We do that by dividing the torque of gravity by sine of 15 degrees times 0.12 meters, and we get magnitude of force from deltoid of 270 newtons.